Okay, on number 1 here. Regular polygon has 20 sides. I always go with the exterior. All right, in this case, we do want to know the exterior and the interior, but because we know 20 sides and it's being regular, 360 degrees divided by 20 sides. So when we go and calculate that, we get 18 degrees for the exterior angle, okay? Then we've been talking about the interior angle. It was always supplementary with that. It always makes a linear pair. So 180 minus 118, that's going to give us 180 minus 118 gives me 162 degrees for the interior. Now, number 2, okay, we're given that an exterior angle of a regular is exactly 18 degrees. So we took that 360 again, divided equally by 18 degrees. And actually, we find out that we have those 20 sides. Now, with those 20 sides, we also want to find the sum of the internal. Well, we know, again, that the internal is supplementary to that. So we can do 180 minus 18 is 162, and take that times 20 congruent angles. 162 times 20, 3,240 degrees. You could also do 180 times n minus 2. And when you do 180 times 18, you get that 3,240 either way. Okay, on number 3, we are given the exterior angle of a regular octagon is 3x. Solve for x. Again, because it's a regular octagon, 360 divided by 8 gives me 45. And x turns out to be 15 then, okay? Number 4, that is the internal angles of a 1, 2, 3, 4, 5. That is a pentagon. So we got to first know how many degrees inside a pentagon. So I'm going to use 180 times n minus 2. We get 540 degrees. So x plus the angles that I know, walk it around. The angles that I know add up to 442 degrees. All 5 of them gives me 540. So subtract that from 540, and I get x to be 98. The largest exterior angle is going to be supplementary to the smallest angle. So since x turned out to be the smallest angle, the exterior angle is going to be, again, a linear pair with that. So 180 minus 98, I get 82 degrees right there. You can go around and calculate the rest of those, but they are not going to be the larger compared to 82 degrees. On letter B, that is a typo. We want to find y right here. Now what we have again is, looks like a pentagon where we got the exterior angles, and we know all the exteriors add up to 360. So we have 70 plus 60 plus 65 plus 40. Those known exterior angles is 235 degrees. Subtract it from 360, and we get y to be 125. The largest interior should be supplementary, should be a linear pair to the smallest exterior. So 40 degrees is my smallest one, so therefore my interior should be supplementary to that and be the largest one. 180 minus 40, 140 degrees. You can check the other ones, but the other ones are not going to be as large as 140 degrees. Okay, number 5. 5 is congruent to 4. Go find 5 and 4. Then m is parallel to n. That is true by converse of alternate interior angles. Converse because I'm starting off with a pair of angles to be congruent. That means the lines had to be parallel. B, 1 plus 7 is 180. M and n are parallel. 1 plus 7 adds up to 180. So that is just same side interior angles. We don't use the converse because we're not trying to prove lines parallel. Letter C, we might be using converse, but I am not. 5 and 6 are a linear pair. Linear pairs do not do anything with 3 lines. M has nothing to do with 5 and 6, so we're going to say none, and it's because a linear pair. Linear pair and vertical angles have nothing to do with 3 lines. Okay, letter D. 1 and 8. Go find 1 and 8. Okay, those are going to be alternate exterior angles. I don't worry about the converse part of it because I'm not trying to prove a conclusion of lines parallel. And lastly, 2 plus 8 is 180, then M is parallel to N. That is where I will use the converse. 2 and 8 are in the position of same side exterior angles. So with 2 plus 8 adding up to 180, the only way that can happen is if the lines were parallel. I'll pause it and upload this.